All right, welcome to the stage, Marian Steininger.
Hello, and thank you. Welcome and thanks for joining us today. This session is Bridging the Gap, Strategies for Integrating Legacy Systems with Modern Technologies. Let's first start by familiarizing ourselves with the event tool. Look at your right-hand side, take a look around for the chat, and tell us where you're located. Please post all of your questions in the Q&A tool, not the chat. It will be easier for us to answer them. A couple of housekeeping items. We're taking questions at the conclusion, so please post them in that Q&A tool. This track will run for 59 minutes, so we will have you out of here on time. It wouldn't be possible to run this virtual conference without our sponsors. Thank you to the sponsor of this session, Influx Data. With housekeeping out of the way, I'd like to introduce our topic, Bridging the Gap, Strategies for Integrating Legacy Systems with Modern Technologies. Our speaker today is Balaji Palani, who is the VP of Product Marketing for Influx Data. He is their Vice President of Product Marketing, overseeing the company's product messaging and technical marketing. Balaji has an extensive background in monitoring, observability, and developer technologies and bringing them to market. He previously served as Influx Data's Senior Director of Product Management, and before that, held product management and engineering positions at BMC, HP, and Mercury. And so with that, Balaji, let's go.
Thank you, Marianne. Hello, everyone. Good morning, good afternoon, and good evening, and joining from wherever you are. I'm super excited to be here talking to you about this topic, which is Bridging the Gap, strategies on integrating legacy systems with modern technologies. I know Marianne introduced me, but I just would like to add a couple of things to my thing and why it's important that you hear me out. Or basically, I've been at Influx for 6 years, 20+ years in the industry. I think as Marianne mentioned, most of my focus has been on monitoring operations and automation. But in Influx, I launched cloud or InfluxDB Cloud. InfluxDB is the time series database, and with that, in that process, I worked with at least hundreds, if not thousands, of customers in onboarding them, in understanding the use cases, in working with them. So I think I have a fairly good idea of the problems that we are facing in a variety of industries, including the industrial IoT that we're going to talk about. All right, so let me begin. So here's what I want to talk about today. So we're going to chat a little bit about the Industry 4.0 challenges. And then specifically, I want to dive into data historian and compare it with InfluxDB. Obviously, you can compare it with time series database, but I'm from Influx Data, InfluxDB. I want to talk about InfluxDB and provide you a bit of an overview. We recently launched 3.0 and what's that about, how it helps customers. And I have some customer examples as well that I'm going to go over, and then we can obviously go with the Q&A. So I'll start with the statement. Digital transformation at scale is the key to higher output and agile manufacturing in industrial IoT. What does that really mean? In other words, industrial IoT customers, I think I've seen who have been successful at obtaining higher output and optimization have really done so by modernizing their stack and adopting technologies which allow them to use data in specific ways and analyzing them in real time. That's what I want to talk about today. So before we head into InfluxDB, I want to maybe start with Industry 4.0 and what the challenges you'll be facing as part of that. So it's not new. This has been out there. We're in the Industry 4.0 age, brought about by better connectivity. You have sensors everywhere. You have 5G, 6G networking. You have automation going on. You have a lot of data. Data is just flowing everywhere that you can take advantage of. You can use in a bunch of variety of use cases all around improving your efficiency, and improving your output, reducing errors, making you better, running faster, adding more industries, adding more output to whatever you're doing. So those are all the things you could do if you can take advantage of this Industry 4.0 stack and technology. I'm going to specifically focus on the operational efficiency, take that as an example, and show you, talk some of the concepts there, and see how you can actually go from, I mean, obviously we're all going across a particular journey, right? We all know about break fixing, scheduled maintenance, but how do you go beyond that into preventative maintenance, or maybe beyond that, use all of these AI, ML, people are talking about what it is and how do we use it in conjunction with the data that you produce to go to predictive maintenance, so that you get better than 90% OEE, or operating equipment efficiency, and so on. So let's talk about it. So just a little bit of the goals that you probably are, you're doing this day in and day out. I'm just summarizing them. I think, from an OT goals perspective, any one of these or combination of these, we see this across many customers. Either you're improving your reliability of your equipment, so overall effectiveness is better. You're improving your efficiency in your lines, so that you're getting better throughput. You're optimizing, and then you're reducing costs, or by replacing those technologies or augmenting those technologies, and you're getting more return on investment. Those are the goals that you're looking for from an operation technology perspective. So why am I speaking about this? I'm from Influx Data, and InfluxDB is a time series database. But here's the thing. All of this industrial IoT actually speak time series. Time series data is nothing but, anything that changes over time. You're measuring some sort of equipment temperature, or pressure, or something that tells you, that senses what your equipment is undergoing today. And all of this change over time. What you measure the change over time is actually what we call as time series data. And they can be events, they can be activity, they can happen just once a day, or every second, or multiple times a second. Most often than not, you would see the time is that manufacturing, the magnifying glass for that operation. And then so you may be using data historian today, but those are, historian means you're really essentially trying to track the history of data over time. So with that said, we do want to start with the first polling question of ours. So if you can bring up the poll, that'd be great. So the first question is digital transformation, in other words, Industry 4.0, an urgent priority for you? Once you have all the goals, maybe I can get some of the polling data. Anyways, so while we are waiting for that, I'm going to go next, and then maybe come back to you at the end. So let's go to the next one. So this is very important for me. I think again, I'm focusing on data historian. I'm focusing on data historian because a lot of you are currently having some form of data historian in your environment. Again, if you don't, that's okay. I'm going to talk about those situations as well. But chances are that you are using something which is the data historian. What is it? What is data historian? So again, you may be more familiar with this, but from my perspective, I feel like a data historian is a very specific application or solution that's built towards working with that industrial data. It's typically deployed on-prem. Its main aim, its main focus area is to capture that data that's produced by your equipment and historize them. It shows you in a specific context. It's very rich and so on and so forth. It's specifically aimed at operation technology use cases. But that's not all. I think it comes with some pros and cons. And I think, again, maybe 10 years ago, data historian was great. It was right and it really fit very well. But today, if you look at the way things are moving, I believe that data historian is becoming a legacy system. And the reason is, Marianne, can I ask you to mute yourself? Sorry. Thank you. So today, if you look at the pros of data historian, yes, they are very built domain specific. It's very well integrated into your OT control systems, and it's an end-to-end system that's really rich in functionality, specifically aimed at your end user experience. But what is not, I've worked with many customers who've said, hey, it's really hard to get that data, extract that data, put it into another system in the cloud or somewhere where they can their data engineers can run machine learning algorithms on it and do preventive maintenance and things like that. So it's a rigid legacy technology. It's closed system. It's not open system. It's difficult to integrate with modern data ecosystem. And to top it all, it is super expensive. You want to add a new bottling plant, a new thing, a new equipment. It's super expensive. You got to work with a lot of systems. You got to work with processes. You got to work with getting that data in. It really prevents you to be more agile in your manufacturing space. Okay, so what's the alternative? An alternative is to look at time series database in general, but specifically I'm going to talk about InfluxDB. InfluxDB is specifically purpose-built for storing timestamp data at scale. We've been in this, trying to do this for the past 10 years. We started in 2014. We had launched our first open source back in 2016. But what it is, it's an operational data platform. You can think about it as an operational data platform that's really built to collect, organize, and take action. So things, you don't have to take logs and try to push it across. The way it's built, the way it's architected, it's really collecting every second, or even millisecond, microsecond. We can collect that data, we can scale that data, and we can take action in real time on that time series data at scale. So it should be, my perspective is it should be a critical technology that should be on the table when you're looking at digital transformation projects. So again, let's look at the pros and cons. It doesn't mean it doesn't come with cons, right? So yeah, the pros are it's built in a very cloud native manner. It's modern, open, and I'm going to talk about some of the architecture later on. It natively supports SQL. So if you have a data engineer, they can extract that data using SQL. It has some advanced analytic capabilities to use with time series data, windowing, and things like that. It performs really well even in real-time processing. If you need something as soon as the data drops in, you can work on it and you can query that data. Cost efficient, we built it in such a way that you can store data forever with all the detailed granularity that you have, but you don't have to pay top dollar for that. And it can support massive scale. You can look at edge to cloud. I'm talking about edge to hub and all of those things. It really supports those hybrid deployment models. So all of these are pros, but there are some cons. It's not a single solution. It's not like you can take and replace data historian today with just influx data. You can think about InfluxDB as a build versus buy. You're building the solution. InfluxDB forms one of the solutions, and then you might have to use Grafana. Grafana is a great visualization tool. You will use Telegraph. It's an open source tool to grab data. You would use Ignition. You'd use Seek. So there's a number of things you would use, but it's actually better if you do it this way, because then you're building in a modular fashion. Then you're building, you're really looking at the pros, and you're getting the data in very open format that you can use, or your data engineers can use for doing machine learning and so on. So there are a lot of pros, but of course, this time it is a build versus buy decision that you will have to take. So some of these customers, they're all They have done this path, they have done this journey on going from kind of adopting modern technologies such as InfluxDB, doing the digital transformation. Again, I wanted to show here that it's not just one industry. Either you are in a smart manufacturing, mining, or really PTC is one of our partners as well. They work with several of their customers who are doing industrial automation as well as Schneider Electric. All of these are customers of InfluxDB, but they also do that kind of digital transformation. They're leaders in that space. So with that said, this would be a second polling question. What are you looking to do with your industrial IoT data? Again, there are some options there. Either you're improving your operational efficiency and reducing costs, or you want to enable predictive maintenance and minimize the equipment downtime, or you want to enable agile manufacturing, so you want to go faster time to market, or all of the above. Again, please submit your poll. Okay, so I'm going to go to the next one. Okay, there you go. So yeah, there are some results. So most of you have said all of, or 67%. That's really great, because this is something that we see in working with customers as well. Like they're actually looking at everything. You want to improve operational efficiency and reduce costs. You want to do predictive maintenance, and you want to be agile. You want to. It's not like you want to be stuck doing the same things. If you are adding a new manufacturing one, you may want to do that. So thank you. So let me go to the next one. So this is a kind of a, you can think about it as a blueprint, a very high level blueprint of how you would do digital transformation with InfluxDB. It does focus on InfluxDB. There are other things like Grafana and things like that, but we can talk about it. So chances are your data sources are doing something of the form of SCADA, PLC. They're talking in OPC UA protocols and things like that. Now let me talk about Telegraph. Telegraph is an open source agent. It's open source, meaning you don't have to pay for it. You can download it, install it. It can run on anything, as long as you can. We have some OS requirements, but you can run Telegraph pretty close to where your edge is, and you can talk OPC, Modbus, Ping. There are a lot of plugins, that 300 plus plugins, and extract that data and then push it into InfluxDB at the edge. At the edge, it's a very small installation. Typically, this will be installed for facility or for equipment sometimes if you have some challenges on putting it per facility. But the main aim of this InfluxDB at the edge would be to collect, transform, replicate. So you're collecting, you're doing some transformation. If you stick Grafana on top of it, this becomes your kind of tool that your field technicians can use, because there's high fidelity data. You're collecting all that data every second, even multiple times a second. It's collected at the edge, so you can look at it. You can also do downsampling and look at the summary of that data. Then the other thing that you could do is you can set up replication. You can say, hey, I want to replicate this as soon as the data arrives, either in as the raw data format or in summary of that format. So you can do both, and then you can replicate to your cloud environment, or it could be another enterprise environment that is not in cloud. It could be on-prem, but you can replicate to that. You do have to have connectivity, and the beauty about this thing is when your connectivity drops, we store that in a queue. So all of that is possible. You can replicate it, put it in the central hub, and this gives you the option of the high fidelity data for your field technician. You can do advanced analytics, long-term retention. You can do trend analysis. You can also do ML. So all of those things are being done on that cloud or central hub. So this just talks about Telegraph. Again, I talked about how it's open source. You can install it. It has a bunch of plugins, OPC, MQTT. Hey, I'm actually putting it into AWS IoT core. Great. I'm putting it into Kinesis, Azure Event Hub, Kafka. So it has a bunch of plugins where you can extract that data, and you can also transform that data to some limited extent. You can do, hey, I want to add additional tags, I want to drop a particular thing. So those are possible within Telegraph, and then you send it to InfluxDB. Another beauty about Telegraph is it's not just to InfluxDB, you can send it to other places as well. So there's input plugins, modifying the plugins to modify that data, output plugins, and things like that. So this talks a little bit more detail about the edge and hub architecture. So you can run multiple InfluxDB open sources at your edges, a single enterprise or cloud at the hub, and how you can replicate all of that data into a central place. So this gives you the advantage of either you can look at it and do comparisons. You can do also collectively take all of, maybe there's a particular plant or factory which is doing very well, highest efficiency. So you can take all of that data, run through machine learning, and apply that, train that model, and take that model and apply that to rest of it, and see where, how you can improve efficiencies in those things. So this also does another thing, right? So your data is not located just in your edge. Your data is not located in silos. Now, all of a sudden, you have access to all of that data, and your data access is simplified. We use secure transportation, also data at rest. So you don't need to worry about security. It's lightweight. It's an open source. You can install pretty much in a smallest machine possible, or VM possible, that you want to have at the edge. So there's a lot of advantages of doing that. Last polling question. I promise I won't have any more of this, but there is one more question I do want to understand. Hey, do you have sensor data at the edge? Is this a use case that you're looking to solve, that you want to bring into a central location? Okay, so let me move into the next one. So let's talk about, I think I talked about edge, where you can use open source. Now I want to introduce InfluxDB 3.0. 3.0, we launched 3.0 just last year, multiple editions, but we are very excited about this 3.0 because of the new database and storage engine that we were able to do. So in essence, what is 3.0? There's probably 3 or 4 things you can remember about 3.0. One is it's very high speed ingest. We can ingest billions of time series data at high resolution granularity. So that allows you to analyze massive amounts of data without any delay. You can do it in real time. So ingestion is very efficient. And I'm going to talk about a little bit how we made that efficient, right? This was super important. We are already efficient in the previous versions, but we have pushed it even further in 3.0. Another thing this brings to the table is real-time querying. Because of the architecture, actually InfluxDB is able to give you sub-second responses. So as soon as data lands, you can actually query that data for that recent edge that we call, or live incoming data. So immediately, as soon as it lands, it's not, you're not going to wait a second or 2 seconds. It's useful for mission critical application. Maybe you're doing space launches or things like that. Again, it may not relate to manufacturing, but sometimes it does, right? So you might want to know, as soon as data comes in, you want to run a script or something that automatically detects anomalies and things like that. So it does allow you to do that real-time queries. We also, the technologies that we're using allows you to compress the data. And when we store that data, it's stored at very high efficiency compression. So what does that do? That allows me to take the smallest footprint and reduce the cost, because again, data comes with a cost, right? So you store it for 10 years because you want to run machine learning, or you have a regulatory requirement and things like that. You may want to store it in the lowest cost possible storage. So that's what we do with 3.0. And another thing we also do is unlimited cardinality. So there are a lot of cases where you may want to know, collect that data with highest granularity, with all the context that's available. So you can do that with InfluxDB 3.0 and keep it forever, right? So that's another key thing. So how is it possible? We are actually, this may be a little bit technical, but let me explain a little bit. I try to really explain in the simplest terms possible. So we do use some technologies here, right? So these are open source Apache Foundation technology stack. So it's called as Aero, Apache Aero Flight. It's really possible to transfer data at high speeds. Again, the fundamental concept with 3.0 is we saw that columnar databases are really fast. It's faster in terms of ingest, it's faster in terms of transformation or analysis, it's faster in terms of storage. It takes smaller disk space. So we try to incorporate in all of these technologies that we chose. Open source, it's an Apache Aeroflight, is for transporting columnar data at high speeds. Data Fusion is a query engine. Again, it is open source. It's written in Rust, really fast. Aero, when data comes in, it's all optimized. Every component within InfluxDB talks Aero, so you don't have to take the data, push it here, serialize it, deserialize. All of that is eliminated. We are making it really fast, efficient for you. Parquet. So Parquet is another storage file format that you could store, pretty open. You can use with machine learning. If you're a data engineer, you may be familiar with Parquet. You can use it in Amazon S3 or Athena or Snowflake and things like that. So you can do all of that. So by default, we are using these technologies. So we are making it faster, flexible, scalable. So some details about, again, I mentioned, hey, we're using Parquet and we store it on the object store. What does that give you? It gives you anywhere from 80 to 90% storage cost reduction as compared to if you're storing it on disk, on Elastic EBS, Elastic Block Storage or things like that, which is SSD, which is great with performance, but really expensive. We are taking care of it. InfluxDB automatically stores it on object store. It uses Parquet, and that gives you better compression and so on. Because we are using Aero, so as soon as data lands, the way we have architected it, we load that data immediately into memory. As folks know, when data is in memory, you don't have to go spend the time on I/O trying to read it from the disk. So, which means that as soon as data lands into InfluxDB, it's available to be queried. So this is why if we can accomplish real-time things. If your data you're looking for, hey, as soon as something happens, I want to automate something like anomaly detection. InfluxDB does provide that kind of capability. It's okay. What about data which is historical? It's stored in Parquet. We all know object storage. It does give you the lowest cost storage, but it does take time. You have to spend I/O to read that data. But here also we have done optimizations. We're using a query engine called Data Fusion. Again, we contribute to it. We have contributed a lot of it. We're active contributors to it. That Data Fusion engine is optimized for efficient data access, meaning if you're looking for, hey, I'm just looking for this column, it knows it'll eliminate, prune all of the other ones. It'll push down predicates. Again, all of these are technology choices, but the point here is we did that to make query responses faster for not just in-memory data, but also which is coming from object storage. In InfluxDB 3, there's additional benefit that you would see with InfluxDB, right? So I talked about how data is stored in Parquet. You could ask, hey, what you're storing their data is in object store that is accessible to InfluxDB. What about I'm using a data lake house? I'm using Snowflake. I'm using something else, Athena. How do I access that? Most often than not, today in the industry, there's you can do ETL. You can make multiple copies of the data, but with InfluxDB, we are making this data available to those data lake houses and those things with Iceberg. Iceberg is an open table format that it's just catalog information that shows, hey, most often than not, your data houses, lake houses can read Parquet, but this Iceberg support integration just helps with locating that data. So when you want to access using Snowflake, they can access it directly, and that gives you you don't have to copy the data. It's just better. It unlocks data interoperability. You're doing it at a lower cost. You're not making multiple copies of your data and so on. And we're not alone in this. We're not saying, hey, replace or augment your data historian with InfluxDB only. We work with Grafana, we work with Seek. These products and tools play a very important role at different layers. And we work very well. We are API compatible. We can be deployed at the edge, in the data center, on-prem or cloud, and we can work with a variety of these. And in fact, we have customers using a different kind of, hey, they're using either IO-based InfluxDB, in the cloud and so on, or they're using Kepware InfluxDB. Some people are using Telegraph InfluxDB, and then Grafana and things like that. So this is a combination. Choose what you will, like how you want to use it. We're all for it. We want to make sure that you're successful with your digital transformation that you have. Some of the customer examples that I just want to spend here. First one, I don't want to name, but it's one of the largest aircraft manufacturing in the industry. They were using a data historian previously, but again, as we know, it was. I'm sorry, I'm having difficulties here. I hope it's just you're able to hear me. So I think here they were using a data historian previously, and it was really hard for them to do any kind of agile. Something changes, a new equipment has to be brought in. It was really hard for them to really look into it. So they actually chose to use InfluxDB, and they are monitoring more than 3,000 parameters per second in that one factory-wide view. They have some strict security and compliance requirements that they were able to meet. They were also able to scale. So all of these became possible with Influx. This is another mining leader. Again, they have one of the largest mining operations in Western Australia. They wanted to be able to use they were already collecting data using some OEM technology, but none of it was in cloud, none of it was aggregated. They were all in data silos. So they wanted to grab that data, get into a single system, and then use machine learning and so on. So they chose InfluxDB as well. That unlocked some of the new use cases that they were not seeing made. Like they wanted to do it, but they never thought was possible. Another energy company, again, my point with all of these is it's not just one area. It's not just built, InfluxDB is not just built for this particular industry. It's a very open that could be inserted or plugged into a variety of different industrial use cases. Here, in this case, OnProve, they're a consulting partner. They work with a lot of customers. Again, they were looking for something real-time, that's scalable, and with InfluxDB, they were able to do a real-time ingest/visualization of 35,000 values per second, getting better success with our InfluxDB than before. So to summarize, I think, again, InfluxDB can provide these benefits, but think about, as you think about your digital transformation, think about InfluxDB as a tool, as one of the things that you should explore to give you the high-speed ingest, to be able to scale horizontally, to be able to interoperate with your data lake houses, to give you the cost efficiency and give you some of the real-time action that you need when you consider these projects that you're in. These are additional resources. Again, if you're interested, we have a very good webinar on industrial IoT. There's a live demonstration run by Ben Corbett, who's one of the SEs, but we can go in depth in some of these things. If you want to know, hey, how we gave you storage savings costs, you can learn more with that resource. Or simply, if you want to run a proof of concept, reach out to us. It's possible. With that, I thank you, and maybe now there's some time we can go to the questions.
Right, let's go to some questions. So the first one is by Ravi Prakash. And the question is, how is the data protection and redundancy carried out? What are the fail-out preventative measures in terms of data loss?
Okay. Can you repeat that question, Marion? I was trying to switch to the Q&A, and I think I missed the first part of that question.
Sure. Yeah. How is the data protection and redundancy carried out? And then the second part of the question is, what are the fail-out preventative measures in terms of data loss?
Cool. Yes, great question. In case of InfluxDB, by default, as data lands, of course, from a security perspective, you can use TLS, SSL, and all those things. But as soon as data lands, it actually, the internal architecture makes multiple copies or replicates that data to make sure it's not lost. So as long as it's landing on Influx, we have replication under the covers. We call it write ahead log, which is replicated multiple times on multiple ingesters. We are able to replicate that, and there's no data loss once you get it into Influx. I'm talking about Influx commercial options, which has that clustered thing. And then beyond that, it goes into I mentioned to you that we store or persist data on object store. Object store is very reliable, very persistent, so data durable. So it offers us so many things. But even if your entire ingester query, entire InfluxDB goes down, we have data available. So yeah, in short, we do make sure data is durable and secure, and we make sure that it's scalable as well.
Great. The next question is from Kai Bush. And the question is, what would you say are the benefits of a time series database over a relational database?
Great question. So relational databases like Postgres, they are built or architected to give you consistency. Because again, they're used in situations where, for example, if you have a banking transaction, you're subtracting money on one account and adding money on the other. You want to make sure all of these are consistent across any nodes that you query from. But you can use the relational database by adding a time column to store time series data. That will work as long as you're looking for scale. The moment you go for scale, there are a lot of things that a relational database that you could encounter that doesn't simply scale to handle all the incoming kind of barrage or volumes of data that you might experience with in a high scale situation. InfluxDB or time series databases, really good time series purpose-built databases, they're purpose-built for that. You will see that like InfluxDB, we are eventually consistent. Eventually, we will be consistent, but we prioritize availability of writes. So you can send in like millions of writes, and we will take in. And because our write pipeline is very, very simplified. We just take in, we verify a few things, and then we just push it to disk. We don't spend time on analyzing, oh, is that column consistent with this one? Should I make sure this data is here and here? So all of these things are eliminated. So that's why making it faster for ingest, also for queries and so on.
Great. The next question is from Rashid Kokar. Could you please provide insights on the current best practices and benchmark methods for enabling privacy-preserving deep learning in industrial IoT setups? And the second part of that question is, how can they be effectively implemented?
Yeah, this is an interesting question. Insights on current best practices and benchmark methods. We do have like our performance team. They run some benchmarking on a number of aspects. And again, this is not a simple question that I can just answer. Hey, do X, Y, Z. I can possibly come back to you guys with what they do on our performance team, and then maybe give you guys some insights into what what they look at.
Okay, the next question is from Nicholas Quinard. How do your edge secure and up to date with security updates?
Yeah, this is a great question. Since in my presentation, I've used InfluxDB open source at the edge. It's really open source. Again, it's a great product, but some of these security things you would have to secure them at the edge, right? So of course, when you can set up SSL and things like that, but in terms of data security at edge on disk and all of those things, there are options that you can do, and we can provide you the details, but you are responsible for securing that edge, including making sure they're up to date with security updates and things like that. There are a lot of software out there which can help you do that.
Okay, the next question is from Tom Gassenbeek. I am intrigued with the 300 plus plugins in the Influx database Telegraph data collector, but it's missing MT Connect for CNC connectivity and machine tool real-time data gathering. Is this something you're looking at?
Maybe we probably are not, but I'm pretty sure. And now I can go back to the team and then make sure that we look into this. If it's something that, hey, here's another thing about Telegraph. We have a lot of contributors. It's an open source project, so if you, and it's very, I wouldn't say it's very easy, but it is possible to build a specific connector or plugin. We provide the kind of the artifacts for it. If you were to build something yourself and you wanted us to include it, that team would be very happy to work with you and get that. We are unfortunately not the experts in CNC connectivity, so maybe this is an opportunity for us to work with you. So I'm happy to get back to you guys.
Great. The next question is from Prasad Manaratha. With all the software and tool names available, it is confusing who are the suppliers to work with. What's the best way to go about figuring out the best architecture and suppliers?
Yeah, this is a great question. Again, we provide options, and I wish they could be, hey, because again, you're dealing with an industry that has multiple tools. Again, if you start now, for example, today, I could probably provide you, hey, start with Ignition. Ignition has great SCADA kind of data. You can extract that data, and then we can work with you on how you can go from extracting data from Ignition into InfluxDB and so on. We can definitely look at that. But this industry over the years have implemented, chosen to use a lot of tools. So we just provide options of, hey, how you can implement with that particular tool, or maybe and use it in your environment of choice and so on. But it's a good question. Most usually, this is also happening at the same time as I speak right now. We are actually at Influx Data, we recognize this is a problem. We are actually working with a lot of our partners. These partners are system integrators. They're more familiar with industrial settings, industrial automation. They do a sort of an audit at your end and figure out, hey, these areas need internet connectivity, and these areas we can extract data in this way. So again, some of these partners are A&E engineering, SIIO is what they've renamed themselves to, or even their Rockwell Automation. There are a lot of other partners like that we are Rovisys consulting. So we are working with them to ensure that each one of these partners know how to talk about or even implement InfluxDB. So stay tuned, and you would see that some of these partners will come up with, hey, this is a reference architecture that we have built with InfluxDB. So if this is an urgent priority for you, reach out to us. We will help you get started with a partner as well.
Great, thank you. I have another question. What integrations are provided out of the box in InfluxDB to get data from SCADA systems?
Out of the box, I mentioned OPC UA, Modbus, MQTT. I think I might have missed in my slides, but there's a partner, Terrega. They They work with gas and oil companies or gas pipeline companies. They built their own hardware like IO base, which gets installed on your kind of on-prem. And IO base has all of the things necessary to extract that data from your SCADA systems. And then they have a ingest or integration into InfluxDB as well. Again, so if you're in that industry, Terraga is a great partner to work with. We have one of the largest brewery using PTC's Kepware. They use Kepware at their on-prem and then use Telegraph. I believe they use Telegraph to extract that data from Kepware into InfluxDB. So there's multiple ways you can do it. So yeah, but those are some of the plugins that I've seen being used.
Okay, another question is, how does Influx Database handle data security at various points?
Sure. Great question. So InfluxDB by default, right? So I mentioned if you're using one of those commercial options, it's made encrypted at rest, right? So as data lands, we encrypt that data, and when you're sending that data through the network and so on, we do use APIs, and the APIs have you have to turn on SSL or TLS, and for example, if you have applications trying to access that data, we ask you to work with tokens and authentication. So we have different methods of authentication. If you're trying to access it yourself, we have kind of integrations into SSO, enterprise SSO. We can do that. Or if you're trying to build an application, you have to generate a token that will allow you specific access credentials to specific buckets or data. So you can do all of that. And so we do support a variety of these security, enterprise-grade security options that you may be looking for.
Okay. I have a question. There's a lot of industrial companies that have invested in data historians. What is your strategy for working with these historians? Is it a rip and replace? Is it a coexistence? How can they optimize their investment in a data historian and still be able to utilize the new technologies in Influx Database?
This is an awesome question. So it's always about, okay, I have a sizable investment in my current tool, which is the data historian. I don't think rip and replace should be your only option. Again, you could do that, but better, we believe that augmenting, for example, if you're using data historian today, and then you adding a new process or new equipment, think about maybe do a small evaluation, put the sensors in, put the SCADA, the different tools, use InfluxDB at the edge, use Grafana to look at the visualizations, because then you would see what's missing. Maybe, again, we're not going to give you one-to-one, hey, you're using a very rich UI with data historian, and you get Grafana, which is completely rich as that. That would never be the case. You would have to build all of these yourself. But the thing is, you're investing in technology which is for the future. You're getting the data out into InfluxDB. You're building Grafana. You're building visualizations. You're setting up security roles and so on. So you'd see that once you start to build that, you'd see the advantages. You can run machine learning on that data and so on, and you can do it in real time. So look at those advantages. Then you can start to figure out, okay, how do I now maybe in cases where you want to see real benefits, right? You're investing millions on this side of your data historian. So see how much it costs to run this stack. Once you do that, you can see the ROI. Then you can build a plan towards, okay, how do I slowly move into this? Maybe you need both. Maybe some areas you would never be able to replace your data historian. Maybe that's static, and why would you do that, right? So you already spent your millions. It's already sunk costs, but it's working. Maybe that continues to be the case. But InfluxDB, this stack, the modern stack, that modern approach that I'm talking about, gives you different options. That's what you should be looking at.
Okay, great. Thank you. Another question is, how would I do predictive maintenance in Influx database?
Sure.
Or InfluxDB?
That's a great question. So, contrary to belief, InfluxDB does not run or support any machine learning things. We are a time series database. We are a time series database that has APIs that can store data. We are very good at storing, persisting the data, and responding to queries in real time, and so on. So your machine learning or predictive maintenance things that you're running will sit outside of Influx. Maybe it's in one of those data tools and being run with your data engineers. And we have many customers who have done that, by the way. You can either use APIs to get that data, run your machine learning, train your models, and then put it back, or then do the predictive forecasting, push those data back into Influx. You can do that everything to API. But with the new InfluxDB 3, we also have Iceberg support. Iceberg allows you to get access to those Parquet files directly, and gives you that ability to not do the copy and movement of the data and so on and so forth. So those are things that you can explore. Again, Iceberg and things like that are pretty new. They're pretty cutting edge technologies. So you would see a lot of changes in this space.
Okay, great. I'd like to point out we still have a couple of minutes left if you have more questions, but I do have another question. Are there some industries that are better suited or can get the most benefit out of using InfluxDB?
I mean, I think I would like to say yes, because of the success I've seen customers have. I've seen customers in energy. They have done a lot of, because again, maybe it's just the innovation, or hey, energy, there was a crisis recently, and maybe they had to look at transforming and doing that digital transformation. I've seen energy, aerospace. Aerospace is a very nascent kind of industry where everything is being built today. So maybe they don't have the baggage. Manufacturing is another one. But manufacturing is, again, you got to, that's where you have to say, hey, maybe you have a lot of investment on your existing tools, and how would you carefully plan and introduce new tools. So yeah, energy, aerospace, manufacturing, mining. I think those are the areas where we have seen a lot of success in these areas.
Okay, great. We still have a couple of minutes. So Balaji, I'd like to ask you, are there any questions that you think the audience should have asked you, but didn't, about InfluxDB?
No, I think these are very good questions, and it's been great to have. Thank you for having me and in the session, and thank you for listening.
Okay, great. Well, we have a couple of minutes, but I'm gonna wrap up the session so you'll be able to get on your way a little bit earlier. So again, I'd like to thank our speaker, Balaji Palani, for his amazing insights and knowledge in bringing us this new information. Thank you to the sponsor of this session, Influx Data. We couldn't have done this without you. Your support ensures we have all of this great content to share. Thanks to our attendees for listening in. Thanks for your great questions. There are a few more minutes if you have some. But if not, we'll put you in the queue for the next session, which is From Data Overload to Actionable Insights, Mastering Data Management in Manufacturing. So that session will be on in about 5 minutes. Again, thank you to our sponsors. And again, the session starts at noon Eastern Time, so in about 5 more minutes.